Hi dear children, welcome to today's class. Today we are going to discuss the first chapter of 11th standard, that is sets. Then what is this set? Okay, set is a well-defined collection of objects. Set is a well-defined collection of objects. Well-defined collection of objects, that is called set. Well-defined means it is possible for us to say whether a element belongs to that set or not without any doubt. Okay, that is the meaning of this well defined. Example, in mathematical examples, the capital N, that is the set of natural numbers. Capital N, that is the set of natural numbers. Capital Z, that is the set of integers. Capital Q, that is a set of rational numbers, and capital R, that is the set of real numbers. So N, set of natural numbers, Z, that letter is used to denote set of integers, Q, set of rational numbers, R, set of real numbers. And if you have Z plus, which means the positive integers, Z plus means positive integers, and Q plus positive rational numbers, R plus positive real numbers. Okay, these are some mathematical examples of sets. A, E, I, O, U. This is also a set. A, E, I, O, U. This is also set. Set, we will enclose all the elements in set inside a curly bracket, and we will separate that elements by using commas. Okay, we will separate all the elements in a set by using comma, and we will enclose that inside a curly bracket. Now, usually we will denote capital letters to represent sets. Okay, capital letters to denote set, and the elements are represented by small letters. Okay, that elements may be numbers, words, letters. Okay, that is up to the nature of our sets. Now, in the set, we can see that E is an element of the set. Okay, E is an element of the set capital A. Then we will use the element of a set to denote the element of a set. We will use the Greek letter epsilon. We will say that E belongs to capital A. If small letter E is an element of our set capital A, then we will use this Greek letter epsilon to represent the elements, and we will read it as E belongs to capital A. Okay, E belongs to capital A. And we know that R is not an element of our capital A. R is not an element of capital A. Then we will write it as R does not belongs to capital A. R does not belongs to capital A. If one element is a member of our capital A, then we will use epsilon, that is E belongs to capital A, and thus R does not belongs to capital A. And set, we can represent the set in two ways. The first one is roster or tabular form. The first method is roster or tabular form. Okay, very simple. This roster or tabular form means we will list out all the elements. Okay, we will list out all the elements. The elements are being separated by commas and are enclosed within curly braces. Okay, we will list out all the elements. List out all the elements. All the elements. We will enclose that inside a curly braces, and we will separate that by commas. Okay, example, set 1, 2, 3. This is roster form. a set A, E, I, O, U. Okay, a set 1, 2, 3, etc. Set 2, 4, 6, etc. All these are examples of roster or tabular form. Roster or tabular form, we will list out all the elements and we will enclose that elements inside the curly braces and we will separate that by using commas. That is our roster or tabular form. And the second one is set builder form. Second one is set builder form. Set builder form. Okay, in this, all the elements of a set possess a single common property which is not possessed by any element outside the set. Okay, we will find out that single common property. Okay, here we will write only the property. Okay, we will find out the single common property which is not possessed by any element outside the set. Okay, example. A, E, I, O, U. Okay, what is the speciality of these elements A, E, I, O, U? We know that these are the vowels in our English alphabets. Okay, here we list out the elements. So this is in tabular form or roster form, and if you want to write the set builder form corresponding to this, we need to find out the common property possessed by all the elements of the set. And that property is these are the vowels in English alphabets. So we will write the set builder form. Let it be A. Then A is equal to set of all x such that, you should read it as set of all x such that X is a vowel in English alphabet. X is a vowel in English alphabet. Okay. This is the set builder form corresponding to the set. Okay. The first one, that is tabular form, we will list out all the elements. And the second one is set builder form, we will find out the common property. Okay. One more example. A is equal to set 2, 4, 6, etc. What is the speciality of those elements? We know that this is even numbers, even positive natural numbers, right? So we can write it as A is equal to set of all x such that x is an even positive natural numbers. Okay. So one is in tabular form and the second one is in set builder form. Now we have different types of sets. We have different types of sets. The first one is empty set. Okay. Empty set means there is no element in the set. A set which does not contain any element is called the empty set or null set or void set. Empty set or null set or void set. Okay. This means a set which does not contain any element. There is no element in the set. Okay. That type of set is called empty set. Example. Capital A is equal to set of all x such that 1 less than x less than 2, comma, x is a natural number. X is a natural number. Okay, tell me the elements in A. Is there any element in A? This is given in set builder form. I'm going to write the tabular form. So A is equal to, what is the first property? 1 less than x less than 2. X should lies in between 1 and 2. And the second property, that should be a natural number. As we all know, the natural numbers, that is 1, 2, 3, etc. This is our natural number. Is there any natural number lies in between 1 and 2? There is no natural number lies in between 1 and 2. That means there is no element in our capital A. So this capital A is empty set and we will use the simple phi to represent empty sets. Okay, we will use the simple phi to represent empty set or to calibrations with no elements. Okay, this is the representation of empty set. Empty set means there is no element in the set. If you have a set with no elements, then that set is called empty set. And the second one is finite set and infinite set. Finite set and infinite sets. Finite and infinite set. Okay. Finite set means suppose A is equal to 1, 2, 3 and B is equal to 2, 4, 6, etc. What is the difference between A and B? We know that in A we have only 3 elements and B we have infinitely many elements. Okay, this is the definition of finite and infinite set. Finite set means a set which is empty or consists of a definite number of elements is called a finite set. If your set has only a finite number of elements, a definite number of elements, then that set is called finite set. This is finite set. And the second one, we know etc. simple is the, okay, this means the set has infinitely many elements. So this is called infinite set. Infinite set. Okay. Next one, equal sets. Equal sets. Two sets, capital A and capital B. Two sets, capital A and capital B, are said to be equal if they have exactly the same elements. Okay. The two sets, capital A and capital B, are said to be equal if they have exactly the same elements. Okay, example 1, 2, 3, 4 and B is equal to set of 4 like such that 1 less than or equal to x less than or equal to 4, comma x is a natural number. Okay. B is equal to set of 4 like such that 1 less than or equal to x less than or equal to 4, comma x is a natural number. Okay, thus B is given in set builder form. Just tell me the elements in B. Okay, or write the corresponding tabular form. 1 less than or equal to x less than or equal to 4. That means our x lies in between 1 and 4. Here we have less than or equal to, so we can include 1 and 4. And the second one is x is a natural number. We need to list out only the natural numbers which lies in between 1 and 4. That is 1, 2, 3, 4, right? What is the speciality of these two sets? Exactly same elements we have in A and B. Then we can say that A equal to B. If you want to say two sets are equal, we should get exactly the same elements in that two sets. Then we can say that two sets are equal. In this case, A equal to B. The order of elements is not important. Suppose B is equal to 2, 1, 4, 3. B is equal to 2, 1, 4, 3. In this case also, we have exactly same elements in A and B. The order of elements is not important. In this case also, we can say that A is equal to B. Now, subsets. Okay, subsets. A set capital A is said to be a subset of capital B. A set capital A is said to be a subset of set capital B if every element of capital A is also an element of capital B. If every element of capital A is also an element of capital B, is also an element of capital B, then we can say that A is a subset of B. Okay, if you want to say A is a subset of B, then you should check whether every element of capital A is an element of capital B. If every element of capital A is an element of capital B, then we can say that A is a subset of B. And subset, for that we are using the simple A subset B. If every element of capital A is also an element of capital B, then we can say that A subset B. Okay, A subset B means small letter A belongs to capital A implies small letter A belongs to capital B also. Okay, A subset B means if one element belongs to capital A, means that element is also belongs to capital B. Now, A subset of B, we can say that B is a superset of A. B is a superset of A. This means B is the biggest set and A is the smallest set. All the elements in A belongs to B. Okay, either you can say that A subset of B, or you can say that B is a superset of A. B is equal to 1, 2, 3, 4, etc. Okay, this is our set of natural numbers. A is equal to 2, 4, 6, etc. In this case, is A a subset of B? Yes, we know that all the elements in A that belongs to B. Okay, this is set of even numbers and this is set of natural numbers. We know that this even numbers is a subset of B. We can say that A is a subset of B. All the elements in A that belongs to B also. Or you can say that B is a superset of A. Or you can say that B is a superset of A. Now, we have two trivial subsets. Okay, we have two trivial subsets. Suppose A is equal to 1, 2. Suppose A is equal to 1, 2. Then the trivial subsets of A, that is 5. 5 is always a subset of empty set is always a subset of A because there is no element in the empty set. And we can say that this empty set is always a subset of A. And the second one is A itself. Okay, these are the trivial subsets. Trivial subsets means always these two subsets will be there for any sets. Okay, if A is equal to 1, 2, we can say that the empty set and A itself. Okay, these are two trivial subsets of our A. Now, if you consider set of real numbers, we have some interval notations. Set of real numbers, we have some interval notations. The first one is closed interval A comma B. You should read it as closed interval A comma B. Okay, square bracket means closed interval. And the second one is open interval A comma B. Here we are using ordinary brackets. Okay, ordinary bracket, you should read it as open interval A comma B. And third one is closed at A, open at B. And fourth one is open at A, closed at B. Okay, now we will look what is the meaning of this closed interval A comma B. Closed interval A comma B means a set of all x such that. Okay, if you have square bracket, that means that number is also included. A less than or equal to x less than or equal to b. A less than or equal to x less than or equal to b. So, closed interval A comma B means set of all x such that A less than or equal to x less than or equal to b. Okay, these two values is also included. We need to list out the real numbers which lies in between A and B, and thus A and B is also included. And here it is set of all x such that A less than x less than b. If you have ordinary brackets, it means that two numbers is not included. You need to list out the numbers that lies in between A and B, where that A and B is not included. Okay. Now the third one is, here we have square bracket at A. That means that A is included. And open bracket at B. That means that B is not included. If you have square bracket, then you will have less than or equal to. If you have ordinary bracket, then you will have strictly less than. Then this is equal to set of all like such that here open bracket at A and closed bracket at B. Okay. In this interval, A is included, but in this interval, A not included, but B is included. So if you have square bracket, which means included, okay, and open bracket means that number is not included. Now, power set. Okay, before that, if you want to find out the length of an interval, okay, length of an interval, that is, if it is square bracket or ordinary bracket, that is not a problem to find out the length of the interval. So length of interval in general, that is equal to B minus A. Second number minus first number will give the length of the interval. That means if you want to find out the length of the interval 3, 7, open interval 3, 7, the length is 7 minus 3 equal to 4. Okay, if it is square bracket, then also you will get 4. Okay, so if you are going to find out the length of the interval, then no need to bother about the brackets if it is square bracket or ordinary bracket. Just second number minus first number, that will give your length of the interval. Power set. Okay, power set means the collection of all subset of a set A is called a power set of A. The collection of all subsets of A is called the power set of A. Suppose A is equal to set 1, 2. If you want to find out the power set of A, we need to find out all the subsets of A first. Okay, as I said, for any sets we can find two trivial subsets, that is empty set and that set itself. So the first subset of A is empty set and the second subset of A is that A itself. Now take all the elements, then we will get Singleton 1, Singleton 2. Okay, I forgot to say what is Singleton set. Singleton set means a set with only one element, that is called a Singleton set. A set with only one element, that is called a Singleton set. So this is Singleton 1, Singleton 2. Okay, now if you want to find out the subset, first we will write that empty set and that set. After that we will write Singleton sets. After that, take all the possible combinations of two elements. Here we have only two elements and that is our set itself. So we got 4 subsets of this capital A. This power set of A, that is denoted by P of A. Power set of A, that is denoted by P of A. So P of A is equal to set 5, set 1, 2, set 1, set 2. This is our P of A. Now, in the set, we have 2 elements. The number of elements in A is equal to 2. N of A means number of elements in A. That is equal to 2. And number of elements in P of A is equal to 4. Number of elements in P of A is equal to 4. Is there any relation between this number of elements in A and number of elements in P of A? There is one relation. This 4 we can write it as 2 raised to 2. 4 we can write it as 2 raised to 2. So in general, if number of elements in A is equal to M, then the number of elements in P of A is equal to 2 raised to m. Okay, very important result. Number of elements in A is equal to m, then the number of elements in P of A is equal to 2 raised to m. Okay. Now universal set. Okay. Universal set is the biggest set. Universal set, that is our biggest set, and it is denoted by capital U. Universal set is denoted by capital U. Now we are going to discuss some operations on sets. Operations on sets. The first one is union of sets. Union of sets. The first one is union of sets. Suppose you have two sets A and B. The union of A and B, that is denoted by A union B. Union of A and B, that is denoted by A union B. And the definition of this A union B, that is set of all x such that x belongs to A or x belongs to B. X belongs to A or x belongs to B. This is very important. In the case of union, we are using OR. Okay. For example, A is equal to 1, 2 and B is equal to 6, 7. Then A union B is equal to 6, 7, 2. Then A union B is equal to set. A union B means just list out the elements in A and B. Just list out the elements in A and B. So first I will write the elements in A, 1, 2, and now the elements in B, 6, 7. We have 2. The 2 we already wrote. So no need to repeat the elements. A union B is equal to 1, 2, 6, 7. Just list out the elements in A and B. That will give A union B. And A union B is the set of all x such that x belongs to A or x belongs to B. This A union B is commutative, associative, and A union phi is equal to A union phi is equal to A. A union phi is equal to A. A union phi means all, just list out the elements in A and phi. We know that there is no element in phi. So A union phi is equal to A. A union A is equal to A. And universal set union A is equal to universal set. Universal set union A is equal to universal set. Now the second operation is intersection of sets. Second operation, that is intersection of sets. Intersection of sets. Suppose you have two sets A and B, and the intersection of sets A and B, that is denoted by A intersection B. A intersection B, and this is equal to set of all x such that x belongs to A and x belongs to B. X belongs to A and x belongs to B. A intersection B is equal to set of all x such that x belongs to A and x belongs to B. Here we are using AND for intersection. So A is equal to set 1, 2, 3, 4 and B is equal to set 2, 5, 3, 8. Okay, then A intersection B means we need to find out the common elements in A and B. We need to find out the common elements in A and B. 1 that is not common, 2 that is common in A and B, 3 is common, 4 is not common, 5 is not common, 8 is not common. So just list out the elements which is common in A and B. That is A intersection B. The properties of A intersection B is also commutative and associative. That is commutative and associative. Now phi intersection A is equal to the common elements in empty set and A. There is no element in empty set, then the common element, that also empty set, and universal set intersection A. We know that this universal set is the biggest set. Okay, so the universal set intersection A, that is A, and A intersection A, that is A itself. A intersection A, that is A intersection A itself, and this intersection satisfies distributive law also. Now the third operation is difference of sets. Third one is difference of sets. That is, if A is equal to 1, 2, 3, 4, 5, B is equal to 6, 2, 7, 8, 4. 6, 2, 7, 8, 4. Then A minus B. This is difference of A and B. A minus B means we need to find out the elements in A, but that not in B. We need to find out the elements in A, but not in B. Okay. 1, that is an element of A, that is not in B, so we will write 1. 2, that is an element of A and B, so we can't write. 3, 4, that is also an element of A and B. We need to write the elements in A only. Okay, we need to write the elements in A but not in B. So we will get A minus B is equal to 1, 3, 5. And B minus A means we need to write the elements in B only. Okay, we need to find out the elements in B but not in A. That is 6, 7, 8. Okay, 6, 7, 8. So A minus B in general, that is set of all x such that x belongs to A and x does not belongs to B, and x does not belongs to B. And this is set of all x such that x belongs to B and x does not belongs to A. So this is our A minus B and B minus A. Now complement of a set. Fourth one is complement of a set. Suppose universal set is equal to 1, 2, 3, 4, 5, 6, 7, 8 and A is equal to 2, 4, 6, 8. Then A complement, that is denoted by A dash. A dash means A complement. Okay, and this is equal to, we need to list out the elements in U but not in A, or we need to exclude the elements of A from U. Okay, just exclude the elements of A from U. Then we will get 1, 3, 5, 7. 1, 3, 5, 7. A complement means just exclude the elements of A from universal set. That is our A complement. Now, for the last section of this chapter, we are using some results. The first result is N of A union B. N of A union B. Number of elements in A union B. For that, first we have two cases here. If you want to say two sets are disjoint, you need to check whether A intersection B is equal to empty set or not. If A intersection B is equal to empty set, then we can say that the two sets are disjoint. Okay, so the first one is, if A intersection B is equal to 5, then N of A union B is equal to N of A plus N of B. Number of elements in A union B is equal to number of elements in A plus number of elements in B. And the second one is, if A intersection B not equal to 5, A intersection B not equal to 5, then N of A union B is equal to N of A plus N of B minus N of A intersection B. Now we are going to extend this result in the case of three sets. N of A union B union C is equal to N of A plus N of B plus N of C. Now take all the possible combinations with the two sets. That is N of A intersection B minus N of B intersection C minus N of A intersection C plus N of A intersection B intersection C. So n of A union B union C is equal to n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of A intersection C plus n of A intersection B intersection C.